So in this video, we're going to talk about buffers and how they work. So a buffer is any solution that resists a change in pH. Buffers are very important because you might have certain solutions where you need that solution to stay at a certain pH for optimal functioning of a certain system. And it's really important for that pH to be constant and not disturbed by the addition of any external factors that could change the pH drastically. One example is blood. So human blood basically has a pH of 7.4, and in order for us to function normally, we need that pH to be right at 7.4, and it should not shift based on us of on any basically any factor that can change the pH. Okay, and that factor could be some very acidic food that we ate, or maybe we're having some kind of a health condition that causes that pH to shift. But long story short, blood actually has a very good buffering system that resists that change to pH, which is really important for us. So right now, let's try to understand exactly, what a buffer is made up of. Basically, what's that solution made up of? So a buffer is basically made up of an acid. It should be a weak acid, okay? A weak acid along with its conjugate base, and the quantities are approximately, the ratio of these are approximately 1:1. So for example, you could have CH3COOH, that's acetic acid, and that acetic acid is also commonly known as vinegar. And if you want to get really technical about this, then that vinegar is really a 5% solution of acetic acid. Okay, but anyway, so you have acetic acid, which is a weak acid. Okay, that's a weak acid. And if you take this, if you add acetic acid to the same amount of its conjugate base, which is CH3COO minus, pay attention, the H is not there any longer, and H plus came off, so that's the conjugate base. Okay, then you have a buffer. Okay, now it's important to understand that usually it's very very hard to find, or rather almost near impossible to basically find uh, a conjugate base in the form that we've written out here. Why? Because there's an unbalanced charge out here. So usually the conjugate base is always used in the form of its salt. And that basically means you have a counter ion which just hangs out and does nothing. In chemistry, we call that a spectator ion. So a counter ion for this would be sodium plus. So this one is called sodium acetate. So that molecule is basically a salt. Okay. So if you take this salt and you add it to acetic acid, so let's say you have 2.5 moles of acetic acid, and you take 2.5 moles of sodium acetate. You mix them up. You will end up with a buffer. And what does the buffer do? Once you have this buffer, this buffer will have a certain pH. So let's say for the purposes of our discussion, let's say the pH of this buffer is about 5. Okay, so then the pH is going to stay at 5, even if we add large quantities of a strong acid, for example HCl, or a strong base, for example NaOH. Okay, so that means that there's a pretty good chance that this is going to stay at pH 5.5. Okay. That being said, does it mean that it's going to stay at this pH forever? And the answer is no. And that's because how long it stays at a certain pH is dependent on the capacity of the buffer, and the capacity of the buffer depends on the concentration of the buffer. Okay. Also depends on the system of the buffer, and the system of the buffer depends on, the acid, the weak acid used, and its conjugate base. There are quite a few different factors, but that's beyond the scope of this video. Right here, this video is only basically explain to you what a buffer does and basically how you can make a buffer. Few more examples of buffers would be, let's see, like for example, the buffer in blood would be H2CO3 and HCO3 minus. Okay, that's the buffer in blood. Okay, this is called carbonic acid. It's a weak acid, and that's called bicarbonate ion. Okay, so these are the principal buffers in blood. Okay,